RLC series circuit. But before starting the RLC series circuit, I am going to remind you these three circuits: pure resistance circuit, pure inductance circuit, pure capacitance circuit. There is no pure capacitance circuit. So we know that electric current potential difference are in phase in resistance. Evet, bu no'yu kim yazmıştı? Clean this no please. Okay. And in pure inductance, potential difference is leading the electric current, but in capacitor, potential difference lags behind electric current. Now, in RLC series, I am going to combine these three because I will add R, L, C one after another like this. RLC series circuit. A resistor, an inductor, and a capacitor are connected in series to a generator. Yes, this is the generator. This is R, this is L, this is C. And we know in series circuits, electric currents are equal. This is the point from where we should start. Electric currents are equal. Same electric current on R, on L, on C, even coming from the generator. All they are equal in series circuit. So I'm going to define, according to electric current, potential difference of VR, potential difference VL, potential difference VC. Let's draw the phasor. Potential differences will be defined with respect to electric current. Same, because electric current is same for all components. This is for resistor. Potential difference and current are in phase. But for coil, potential difference is leading. So leading by pi over 2. But for capacitor, potential difference lags behind by pi over 2. Okay, this is potential differences for R, L, C. And if you look at they are the same quantities, potential differences, but VL and VC are opposite in direction. If two vectors are opposite in that direction, the resultant can be found by subtracting. So VL minus VC, I take VL is greater than VC, so VL minus VC is the resultant of potential difference across the coil and capacitor. Coil and capacitor, we subtract them. And VR is in horizontal, VL minus VC is in vertical. How can we get the total potential difference? By using Pythagorean theorem, parallelogram method. So this is total potential difference across R, L, and C. And potential difference between these 2 points is V total. And we can get it because it's a right angle triangle. So which is going to be VR squared plus VL minus VC squared. This is the equation for calculating potential difference across RLC series circuit. And until here, any questions? No? No. Okay, let's go with the next part. When VR, VL, and VC and V total are divided by R, if I divide V by R, V total by R, VR by R, VL by R, VC by R, VL over I is XL, VC over I is XC, VR over I is R, V total over I is total opposition, which is known as total impedance Z. So these equations are very similar. V total is equal to VR squared plus VL minus VC squared square root, but Z, total impedance, R squared plus XL minus XC squared. So X is called, this Z is called total impedance. Phasors are also the same as the VL, VR, and VC. XL, XC are opposite in direction, that's why you should subtract them. But R is in horizontal, so you should add them by Pythagorean to get the Z. Z is the total impedance, which is also can be calculated by V total over I of the circuit. And V total over I calculates the total impedance of the Z of RLC circuit, total opposition. Yani total impedance means total opposition of resistor, inductor, and coil to the flow of electric current. And last equation is to get the angle. What is this angle? What is the angle between the electric current and total potential difference of RLC circuit? And what is this theta? How much? We can get theta by using VLVC VR phasor or XL XCR phasor. Both measures the same angle theta. So tangent theta is the best way to get this. Tangent theta is opposite side VL minus VC divided by adjacent side VR. So inverse of VL minus VC divided by VR is the phase angle difference between the electric current and total potential difference. Sorry, somebody's calling me, so I have to stop it. Okay, and theta is sine theta 1 VL minus VC divided by VR. Here, the same method, opposite side divided by adjacent side. Opposite side is XL minus XC divided by R. So if we divide it, XL minus XC divided by R is equal to, also you can get the theta. Depends on the given of the question, you can use this one. Mostly you are going to use this one. About this, there is not so much question, so many questions. This one is very, very important in the book. XL minus XC, but XL minus XC, not XC minus XL, divided by R. Inverse of that is, inverse tangent of that is going to give you tangent. According to this VL and VC, or XL and XC, which one is greater, which one is smaller, theta can be positive or negative. VL is greater than VC, or XL is greater than XC, so theta is positive. Or VL is less than VC, or XL is less than XC, VL is going to be negative. So if it is positive, you are going to add positive to this equation, potential difference equation, positive theta. If it is negative, you are going to add here is negative theta. About this, there is no questions in your book, but we should be ready for everything. Maybe they can ask. This is electric current equation. This is the total potential difference equation across the resistor, capacitor, and inductor. Okay, questions about this?